Now we come to thermal decomposition. Now pay attention here to thermal decomposition. What are the different products you get when you're using certain compounds? Thermal decomposition. What is meant by thermal decomposition? Mouth shut.
It is used to break down
To break down a particular substance, which will not done,
or come.
or a compound. Substance will say compound, and you will not get the original substance back. Now, suppose, now pay attention here. Suppose you take hydroxides. Hydroxide, that is OH. Hydroxides are OH, having OH. Now, before you start with this, in any chemical reaction, you must remember something called the reactivity series. Have you heard of this reactivity series?
Yes.
Yes or no? What do you know about the reactivity series?
It's like the rate, how do we react? What do we react? I'm not sure. Yeah, the reactivity, the series, it goes from it goes in the ascending order, like in the
Like the most highly reactive metals are on the
I guess
top.
hydrogen is in between.
K, NaCl, PPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPPP
potassium, sodium, calcium.
Okay. Reactivity series is actually a series. Series means arrangement. Okay, arrangement of metals according to their reactivity. So most highly reactive is on top, less, 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 less. So as you come down the line, the reactivity will keep on decreasing till you come to the most inert or absolutely unreactive element, and that is platinum. This series you have to learn by heart, and therefore we write down on the board, and that is you've got first is potassium, then is sodium, then is calcium, then is magnesium, then is aluminium, then comes zinc, zinc, then comes Pb, then comes iron, then comes hydrogen. Okay, hydrogen. After that, you get now copper, then you've got mercury, then you've got silver, then you've got gold, and you've got platinum. And the reactivity is decreasing. Now, why is hydrogen put in brackets, in box bracket like this? Because it's a non-metal, but it behaves like a metal. It behaves like a metal because it donates electrons. Metals donate electrons. So it donates an electron. So, and its reactivity is equal to 1. So if its reactivity is equal to 1, what do you think will be the reactivity of these above hydrogen? Greater than 1, correct? It will be greater than 1. And this reactivity will be less than 1. Followed now? Now what happens is, what does this reactivity series tell us? It tells us that metals on top can displace metals below. Lower will not displace above. This will displace this can displace this can displace this can displace this can displace this, and so on. But these cannot displace those. Under normal conditions of temperature and pressure, under normal conditions. Correct? Now, for instance, you are all metals here. Okay? And this boy, he comes and he sits here. He has come in late. He's gone inside. He has gone and no, sir, he has come inside. First of all, he's come on time. My grandson will come on time. He came and sat down here. This boy has come in late. He's pushed him and sat down in this place. Have I given you the example before? He's pushed him and sat down here. Once he did it. Second time he did it. Third time he did it. What do you think is going to happen to him? He will loudly. He will
displaced.
No, that means okay. He will be simple. What do you think is going to happen to you? When someone pushes you, you're coming early. You're taking your place. This boy has come in late, and like a typical gunda, he's pushing him up and taking his place. He would. Okay, he would try. What else?
He would punch him and kill him.
Okay, fine. What else? He would punch you. Okay, fine. If you could punch him, you would punch him on the very first day only. Why he waited for 3-4 days? What exactly would happen? Even if he pushed him or punched him or kicked him or whatever, he should have done that on the very first day.
He'll complain.
Yeah, he'll complain. He'll complain to the teacher. He may complain to the monitor. He may go and complain to the headmistress. He may go and complain to the principal. He may go and complain to his mother, father, grandfather, great grandfather, and all of them will come into the classroom and hammer the life of this fellow. Correct? Are these normal conditions? Are these normal conditions where the grandfather, great grandfather, and grandmother everybody comes and hammers the life of that child? Is it a normal condition? No. So therefore, what do you think are these are abnormal conditions? What do you think are abnormal? At that time, when these abnormal conditions come into the classroom, they will make this fellow behave himself. How do you think, or what do you think are the abnormal conditions in chemistry when we will make the lower ones react or displace the upper ones? Abnormal conditions. Abnormal conditions. Under normal conditions, they will not. But under abnormal conditions, what is it? Huh? With the catalyst, with extra pressure, with extra heat. Okay, all these are abnormal conditions. We never conduct any experiment using extremities, using extreme measures, extra heat, extra pressure, catalyst, promoter. We never use it because it costs money. If I can do something at ordinary temperature, ordinary pressure, okay, under ordinary conditions, why not? But if there are certain chemicals that refuse to react, then I've got to use extreme measures. Then those extreme measures are high temperature, high pressure, catalyst, promoter, etc., etc., etc. Okay? So therefore, under normal conditions, he was not behaving himself. So under abnormal conditions, we have to make him behave himself. Have you got that message very clear? Yes or no? Yes. That's straight. All right. Now, so
even during double displacement,
will you keep your mouth shut and did not stop getting into your complications? Learn to walk before you learn to run. So now, when you come to hydroxides, how does heat react with hydroxides? If they are hydroxides of the first two elements, potassium and sodium, suppose it is, say, potassium hydroxide and sodium hydroxide, okay? Heat, no reaction. Heat will not affect these hydroxides. But when you come lower to calcium hydroxide, what's the next? Calcium hydroxide. Calcium hydroxide. Okay. Plus what else is there now? Magnesium hydroxide. What else then? Aluminium hydroxide. Okay. Then what else? Zinc hydroxide. What else then? Sorry. Then what else? PB hydroxide. Okay. Now, these hydroxides, when you heat them on heating, will give you the metal oxide. Plus, you're getting your metal oxide. Plus, if this is hydroxide, if it is hydroxide, remember you will get water. Okay, hydroxide means water. Okay, so here what will you get then? Come and tell me. Magnesium oxide plus water. Then what is that? Aluminium oxide plus water. Plus water. Then here will be zinc oxide plus water. And lead oxide plus water. Okay. Now, this is what you will get. What is happening between both of you? Keep your hands down. You sit straight. I will break your hands, both of you. Chop them into bits. Have I made myself clear to you?
Yes.
Good. Now, so these are of middle reactivity. This is highly reactive. Highly reactive. This is middle reactive. Middle reactive. Middle reactive. This is low reactive. Okay? Now, you come to say, oh, so you've got copper. You've got copper hydroxide will give you copper oxide plus you're getting water. Okay? Now, if you're talking about mercury, mercury hydroxide, okay, on heating will give you the metal mercury plus what you're going to get water. Will you get, you are getting metal plus water. Correct? Next one, silver. Silver hydroxide. Silver hydroxide. AgOH. Again on heating, you are going to get only silver and you are going to get water. If you are talking about gold and platinum, they hardly reactive. So remember, as you go very, 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 very low, you get the metal but the water. Why? Because you're using hydroxide. Why? Because you're using hydroxide. And suppose you're using the next part of it. Suppose you're using carbonates. Suppose you're using carbonates. Carbonates. Okay? That is CO3. Correct? Now suppose you're talking about now here again. K2CO3 and Na2CO3 on heating will not give you anything. Cannot touch it. Okay, it will not react at all. But if you're talking about calcium carbonate, okay, calcium carbonate on heating, again, again getting magnesium carbonate, and what happens? Aluminium Al2CO3 whole bracket thrice carbonate. Okay, then you can get zinc carbonate, okay, then PbCO3, okay, then you've got copper carbonate. Now, all these carbonates, okay, all these carbonates are giving you calcium oxide plus carbon dioxide. Here, magnesium oxide plus carbon dioxide. Aluminium oxide plus carbon dioxide. Zinc oxide plus carbon dioxide. Lead oxide plus carbon dioxide. Copper oxide plus carbon dioxide. If it is carbonate, you will get carbon dioxide. If it is hydroxide, you will get water. If you're talking about, again here, if you're talking about your silver, Ag carbonate, okay? Ag carbonate, and if you're using Ag carbonate, Ag2 carbonate, okay? Now what are you going to get? You're going to get the metal plus carbon dioxide. So you're going to get metal plus you're getting carbon dioxide, plus here you're getting water, oxygen, plus you're going to get oxygen here. Plus you're getting oxygen here. Okay? That oxygen that was here is not here, but comes out in the form of a gas. Remember this. It will come to you in the form of fill in the blanks. Is this clear? So lower reactive, you are going to get the metal, carbon dioxide, and oxygen. Now we come to the next part. You're going to get nitrates. Suppose you have nitrates. Okay, potassium nitrate and sodium nitrate. Okay, on heating, will just keep on melting. Will just melt. And what are you going to get? KNO2, nitrite. NaNO2, nitrite. Plus oxygen. Okay, this is what you're going to get. Learn this. If you're talking about calcium nitrate, calcium NO3 whole bracket twice, or you're talking about magnesium NO3 whole bracket twice. We're talking about aluminium Al2 NO3, sorry, AlNO3 whole bracket thrice. Then you're talking about zinc nitrate whole bracket twice. Then you're coming PbNO3 whole bracket twice. Okay? Then you got copper nitrate whole bracket twice. On heating, thermal. What you're going to get here is your calcium oxide plus you're going to get NO2 plus, yeah, plus oxygen. So you're going to get, yeah, plus oxygen. Okay? This is what you're going to get. So here also you're getting MgO plus NO2 plus oxygen. Okay? Shall I write it down on the board or do you all know it? Then you can get, what will you get here? Al2O3. Okay? Plus NO2 plus oxygen. ZnO plus NO2 plus oxygen. PbO plus NO2 plus oxygen. Copper nitrate CuO plus NO2 plus oxygen. Now when it comes to here, AgNO3, okay, here, and AgNO3. What will you get here? Ag plus NO2 plus oxygen plus NO2 plus oxygen. Followed? This is what you will get. So if it is hydroxide, you will get water. If it is carbonate, you will get carbon dioxide. If it is nitrate, you will get nitrogen dioxide and oxygen. And if it is bicarbonate, now it comes to, where will I do it now? Suppose it is bicarbonate. Suppose I take it bicarbonate. Bicarbonates. Suppose you take now NaHCO3 or KHCO3, or you can say calcium bicarbonate. Okay, all right. So what you're going to get here, you're on heating, you're going to get sodium carbonate, potassium carbonate, calcium carbonate, plus water, plus carbon dioxide, plus water, plus carbon dioxide, plus water, plus carbon dioxide. This is to be learned by heart if you want to get 99.999% in chemistry. Don't look at me with such big eyes. That girl got it. 100 and 100 she got. Okay? So this is what you will get. Now, let us talk about when you're eating food. Because when you eat food, there's thermal energy, there's body heat. So you are taking in what are carbohydrates. When you take in carbohydrates, it gets converted into sugar and glucose. If you're eating proteins, it gets converted into amino acids. If you're taking fats, butter, cheese, okay, oil, it gets converted into fatty acids. Whether they're fatty acids, or they're sugar or glucose, or they're amino acids, during respiration, oxygen will oxidize it into carbon dioxide and water, which is thrown out of the body. Is this clear? So this is how food material is undergoing thermal decomposition in the body. All the food that has been eaten up, can it come back to the normal? Definitely not. Is this clear? All of you? So this is the thermal decomposition of hydroxides, thermal decomposition of carbonates, thermal decomposition of nitrates and bicarbonates. Okay, okay, fine. Now read through that. After 5 minutes, I'll tell you exactly how to conduct these experiments in the laboratory. What happens? You can see on the board and you can tell me. Firstly, don't look at me like that. Feeling sleepy? Come on, hurry up. Yeah.
Ma'am, there, look, I know, mercury and silver, their photo also is there.
Huh?
In hydroxide, oxygen is also getting. You see, mercury and silver.
Yeah. No, what else? Oxygen also, yeah. Sorry, I made a mistake here. Correct, you're right. Okay. Come on, now read that properly.
It would be HGO plus H2, right?
Huh?
It would be HGO plus H2, right?
HCO plus
HGO plus H2.
HGO. No, very low, you get metal only. That's why I showed it to you. All O's up to this, up to copper. After that, we come to metal. Where's your book? Come on, here. Read properly.
Ma'am,
Huh?
can she turn the AC off?
Pull off, just pull off. How you pull off?
Just pull the switch.
Come on, learn it properly. Go and fill this up in what I've kept empty. Go and fill up. Hurry up. Quick. Go and fill it up. Paper, pen is there. Let me clean. What is the valency of oxygen, Andrew?
Yeah.
Huh? Valency of oxygen is how much?
2,
And aluminium?
either 2 or 3.
Huh?
Either 2 or 3.
Either 2 or 3 means what?
Variable valency.
Huh?
Variable valency.
Aluminium? No, aluminium doesn't have variable valency. It's got only one valency, that is 3. The formula of aluminium oxide is wrong. That equation is wrong. Why, who asked you to balance it? I only have asked you to write in products. Look at the board, don't look at my face.
From bicarbonate, it is like same,
Ah.
like carbonate, water, and carbon dioxide.
Pardon me?
In bicarbonates, it is
Yeah.
same.
Put it in bicarbonate, you're getting carbonate. Which carbonate you get?
Like means it will be same for all, na? Like carbonate, water and carbonate.
Yes.
So it will-
Next one, hurry up. Look at the equation, aluminum nitrate when on heating, what will you get? What did you get in the above equation?
MgO plus NO2 plus O2.
So then second equation, what will you get?
PNO plus NO2 plus O2.
Where's O2? Where's the O2? Idiot. Why are you looking at me? Huh? What happened? Finish your work on the board. Come on, you'll do your work, hurry up. Now read till there. I finished that. Now next time when I come, I will do displacement and WT composition. Please read up to there and work out all the questions up to there. Get my bag here. Now remember these equations, please all of you start working on the question from the back of the chapter. Huh? MCQ goes to you.
In the book.
Yeah, direction will do. You think, silly. Huh? Yes, yes, yes. Have all of you followed what I explained to you up till now? There's nobody saying yes, nobody saying no also. Will you all follow?
Yes, ma'am.
Now pay attention. Now they have said, they said, looking at the board, okay. Now they said, how will you perform these particular experiments, if at all they are there, given to you in the classroom? So, if you have taken, suppose you have asked to take lead nitrate, yeah. If I told to take lead nitrate, so what happens is lead nitrate is a white powder. It is a white powder. And it take, pay attention, look at me like this. Look at me here. You got a test tube, you take a little bit of white powder and put it inside, and very gently you are heating it. So when you heat that lead nitrate, gently heating it, what will you observe?
You'll observe lead nitrate. There is.
Look at the board. What will you get?
Lead nitrate. So we get PbO plus NO2 plus N.
Yeah, you will get PbO plus NO2 plus oxygen. Now, you will know that, now this is the decomposition reaction, right? Because from that lead nitrate, you're getting PbO, you're getting NO2, and you're getting O2. How do you know that you're getting NO2? Brown fumes are coming out. From where? From the PbNO3. That means PbNO3 got this decomposed. Brown fumes were given out. Oxygen was given out. Oxygen is colorless. You can't see. So it got mixed up with the brown fumes. And PbO, when it is heated and when it is cold also, it will remain yellow. So PbNO3, which is white in color, on heating will give you yellow PbO, which will remain yellow whether it's hot or cold. And of course, brown fumes of NO2 and oxygen have escaped. Is this clear? Suppose you take zinc carbonate, and you heat it. What do you think we get? Look at the board, look at my face. Let him answer that. Let him answer. Look at zinc and carbon dioxide. Now, zinc carbonate is white in color. When you heat it, what are you getting? Zinc carbonate. You are getting zinc oxide and carbon dioxide. Carbon dioxide has escaped into the air, it is colorless, okay. Now, zinc oxide from white will turn yellow. But when it is cold, it will come back to white. Yellow when hot, white when cold. PbO is yellow when hot and yellow when cold. ZNO is yellow when hot, white when cold. That is the difference. How will you differentiate between zinc carbonate and lead nitrate? This is the thing. Is this clear? If they say, how will you differentiate between zinc nitrate and lead nitrate? Both of them give you the metal oxide. However, zinc oxide will become yellow when hot, but remain white when cold. While lead oxide will remain yellow when hot, yellow when cold. That's a differentiation between, that's how you will differentiate between zinc nitrate and lead nitrate. This question will come. Is this clear? What do you mean?
Decomposition of ammonium dichromate.
That is not, it's looking at tough for you, that will not come. That's not there. Dichromates are not in your course. It's an orange color compound. You're just having simple carbonates and bicarbonates. Is this clear? Now, when we come to copper sulfate, last one, copper sulfate. How many of you have seen? Now, it's not down the board. It's not in the board because I've not taught you sulfate. I've only taught you hydroxides, carbonates, nitrates, and bicarbonates. Now, copper sulfate, now this is a very common compound found in the laboratory, so therefore I'm telling it to you. And it's there in the textbook. What is the color of copper sulfate?
Blue.
Blue color. It's blue in color. And when you take a piece of copper sulfate and you put it into the test tube, that copper sulfate actually has got water crystallization inside. How do you know? Because it's a big lump. If it had no water crystallization, it would be powder. But this is actually by giving white powder. And actually, this is a blue crystal. It's maybe a shapeless thing, but it is there. That is put into the dry test tube. Dry test tube. And you're heating copper sulfate very gently. So you're showing the equation on the board. You're heating it very gently. Very gently you're heating it. Now what happens is copper sulfate, okay, copper sulfate 0.5 H2O shows that it is a hydrated salt. Hydrated, meaning it has got water crystallization. This is blue in color. Blue in color. Now when you heat it, you get copper sulfate white powder. White powder. Okay? And on the colder parts of the test tube, you will get water droplets. So the test tube was here. You took that copper sulfate, all right, and you very gently heated it. Very gently heated it. The test tube was dry, but after some time, when you're heating it gently, you will find that as some smoke, that is the water vapors coming out, it condenses on the colder part of the test tube, and that droplets of water are there. From where did the droplets of water come? From the? No, it came from this body. It came from here. There was no water in the test tube. And from where did the water come? It came from the body of copper sulfate. Okay? And how do you know? Because copper sulfate collapsed into white powder. Now, if I take outside water, not that same water, any outside water, and I put a drop on that white powder, it will become blue again. Okay? That's it. That's to show that copper sulfate is a hydrated compound. That's all. These are the two things, lead nitrate, zinc nitrate, and your copper sulfate. How to differentiate between lead nitrate and zinc nitrate, I explained to you. Can you explain to me? How will I differentiate between zinc nitrate and lead nitrate? How? Let her say.
Okay, yeah.
Look at the board. Look at the board. Look at the board.
Yeah. So for zinc nitrate, the after the product will be yellow. It will remain yellow even after when it's hot. It will remain
Zero marks. You.
Okay, so zinc nitrate will be like a white substance. It will be in white color powder. When you heat it, it will turn yellow. But zinc carbonate.
Zinc nitrate is it?
Zinc nitrate, white will turn yellow, while copper carbonate will be
Wrong. You tell me.
zinc. So zinc, even after heating, before heating it will be white. After heating it will be yellow, and even after it cools down it will remain yellow.
Wrong.
Oh, that's right.
I will sit there and I think this is what you should do. Try to associate zinc, Zn, white. Zn and W, no. How will you show that Zn becomes white? Lead is yellow, Pb and yellow, PbO white, Pby, Py. How will you associate? How will you remember that lead remains yellow when hot and when cold? How will you remember that? And zinc oxide will remain hot when it is yellow and hot and white when cold. How will you remember that? Think of some shortcut method. Like as well say, mother goes to the market, something you have to remember all those type of stupid rhymes. No? So how will you remember? Zinc on heating remains yellow and on cooling becomes white. Okay, you just remember one thing. Lead oxide remains yellow, hot or cold. That you remember. Zinc you will remember as yellow when hot and cold when white. And white when cold rather. And white when cold. Come on, tell me, how will you differentiate between lead nitrate and zinc nitrate?
Zinc nitrate is yellow when it's hot and yellow when it's cold.
Oh, Jesus, mercy, from which world are you come? I just can't understand. My goodness, I can't believe that you're my grandson. I just can't believe that you're my grandson. Tell me the difference between lead nitrate and zinc nitrate.
Zinc oxide. Zinc oxide is yellow when it is heated and white.
From where zinc oxide came? I'm talking about zinc nitrate, suddenly I talk about zinc oxide. So where did it come? From my pocket? Tell me. Look at the board, you idiot. Look at the board and see. You,
Zinc nitrate is yellow when hot and white when cold.
oh God, I want to pick up something to
Zinc nitrate.
fling on your head.
Zinc nitrate is yellow and hot.
No, 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 I never said that. You people are full of, I don't know what. There is sawdust in your head. Sawdust. No brains. Lead nitrate, zinc nitrate are white in color. When each one is heated, lead nitrate from white will become yellow lead oxide, which will remain yellow whether hot or cold. And of course, brown fumes of NO2 are given out and oxygen is given out. Zinc nitrate, when heated, gives you yellow zinc oxide, which will remain yellow when hot and become white when cold, and gives out nitrate and oxygen. So what is it in zinc nitrate that will remain yellow when hot and cold when and white when cold?
Zinc or lead?
Mouth shut. Which part of the zinc nitrate? Huh?
Zinc and oxygen.
Zinc and oxygen.
Part of the zinc.
Which compound I'm talking about? And now your elements. Which compound?
Zinc oxide.
Zinc oxide. Zinc oxide remains yellow when hot, white when cold. And what happens to lead oxide?
Lead oxide when heated, it turns
Lead oxide when heated?
sorry. Lead carbonate when heated turns yellow, and when you if you cold it cold it will still remain yellow.
Okay. And what are the products given?
The products are given as lead oxide plus carbon.
Plus
dioxide.
carbon dioxide. Yeah. Okay. Now can you repeat? What's the difference between lead nitrate and zinc nitrate?
Zinc nitrate is
Is what color?
normally it's white.
Don't say no. Big words you don't use. I cannot understand your big language.
It's cool.
Simple. What is the color of zinc nitrate? What's the color of lead nitrate? Before you start the experiment.
Lead nitrate is yellow and zinc.
Oh my God. There's something radically wrong with you. Something radically wrong with you. I cannot follow it exactly. What is wrong with you? Tell me.
Like when so zinc nitrate and lead nitrate both are white in color. When lead nitrate is heated, it forms a yellow compound, lead oxide, which still remains yellow when it cools down. And when zinc nitrate is heated, it also forms a yellow compound when it is hot, but turns
What is
white.
the compound?
Zinc oxide.
Did you say that? Then
And when it cools down, it becomes white.
what becomes white?
Zinc oxide.
Write it down, please, these to you children. what is the difference between zinc nitrate and how will you differentiate between zinc nitrate and lead nitrate? Differentiate between zinc nitrate and lead nitrate. Huh? That's an alloy. I put the alloy, no? Sodium, potassium alloy. Like for example, you say gold, mercury alloy. There is no formula because it's a mixture. That is amalgam, but it's an alloy. It's an alloy, and the special name for that alloy is amalgam. Any metal mixed with mercury becomes that metal amalgam. Have you written on this answer? Difference between. You're writing it now or right next year, don't worry. Now you can sit down there and look at my face.
Lead oxide is the precipitate or the residue.
Residue, precipitate is the same thing. Residue, what happens is what remains behind. Precipitate is what forms and settles down.
I don't know.
Huh?
I don't know. Can I close my books?
Can you what?
Can I close my books?
My God, you can want, I have to tell you to close your book, and then you can put it in your bag also, and then you can take your bag home also. All that you want me to tell you? Huh? Foolish fool?
I got it done.
In addition, what you wrote about that thing, let me see. Have you written it down? Pakka? Clearly? Let me show you that. Just give me a minute. Not nitrite, nitrogen dioxide. Sometimes NO2 is nitrogen dioxide, no? But when nitrate is come, it's nitrogen dioxide. When lead oxide is heated, when lead nitrate is heated, it decomposes into lead oxide, oxygen and nitrite. It's not nitrate, nitrogen dioxide. When lead oxide is heated, are we heating lead oxide? What are we heating? PP NO3 is heating, you idiot. When lead nitrate is heated, you put your lead nitrate, now. Read what you've written down. Did they put nitrogen dioxide or they put that? NO2 is what? What you wrote? What you wrote? All of you?
Nitrogen dioxide.
Only this idiot wrote nitrite. Don't throw your book, I want to see. You're using some other book, is it? How many books have you used? See, he's using, why maths inside in the chemistry book? Why you left all these pages, Farhan? Why you left so many pages? Oh, you're doing the homework, complete next year, okay? Okay. If he composes it on lead nitrate, my God, this boy is really bad. He wants to make me mad. Lead nitrate is heated, nitrogen, it decomposes into lead nitrate. Lead decomposes into lead nitrate. It decomposes into lead nitrate. Then the boy is mad. And you have made him mad. Stay away from him. Show me your book. You don't go, you will not go till you. Hey, who asked you to leave the classroom? I said, get ready. Sit here, back again. Rascals. Again, he put the lead oxide is heated. Lead oxide is not heated, lead nitrate is heated. You can't understand what I've explained to you? Huh? You can't understand. Have you understood what I explained to you? Huh? It turns yellow. When lead nitrate is heated, it turns yellow. It doesn't turn yellow. Lead oxide turns yellow. Lead oxide turns yellow and yellow and yellow. When it cools down, what is this?
When lead oxide is heated.
Lead oxide is not heated, you idiot. Lead nitrate is heated. Lead nitrate is heated. What is that? Lead nitrate is heated and gives you lead oxide. Lead oxide is not heated. Lead oxide turns yellow and remains yellow. Which part of my English sentence you have not understood?
Kept it like that.
No, you didn't keep it. Give it to you, let's smash you. Okay? So, rewrite the whole thing. Just now. Go, you'll go.